Hello, welcome to Mathematics 1B revision. This will be on the topic vectors and integrals. We'll start with vectors, and this is ratio theorem. And the question we have here is on A. Consider 2 points A and B with position vectors A1i plus A2j, and B, B1i plus B2j. Derive an expression for the position vector C of the point C that divides the line segment AB internally in the ratio m to n. So let's sketch. Let's start by sketching the Cartesian coordinate system to show the line segment AB. So we have our x-axis here. So I need to turn my ruler to 90 degrees. We have our y-axis, and then, of course, we have this as 0. Now we can have our segment, maybe we can put 30 degrees incline line. Maybe this will be fine. Let me start it from here. So we have our line, and on that our line, we have this point as point A, and we have this point as point B. Then we have C somewhere, and it divides the line in the ratio m to n, and that is internal division of the line. Now, in order to get the horizontal distance or positions for A, C, and D, I will have to drop a perpendicular imaginary lines from the points to x-axis, just to project the points on x-axis so that we can find their position without any problem. So I'll project that. So on the projection, we'll have point P, we'll have point Q here, and then I have point R. Now, we also need to have a horizontal line that will show us the distance we need. So the first one is here. We can call that distance to a point where it meets C, and then we have another triangle here which has that diagram. So it means this point, we can call it N. Let me use black, call it N, and this one we can call M. Now looking at this figure, we can see clearly, of course, A has coordinate A1 and A2 for X and Y, of course. Now for coordinate B, B point, for point B, we have B1 and B2. And then C that we want, remember we want to solve for C, we can give it coordinate X, Y, the unknown. Good. Now, looking at the diagram, we want point AM. We start by analyzing the position AM. AM is projected to PQ. You can see that in the diagram. And PQ is from Q minus P. Now, when you look at our diagram, the position on Q, the X position of Q, the X position of Q is on C, and that one is X. You can see that. So the x position is on C, which is x, minus the x position on P, which is A, is A1. I hope this is clear. Now let me just put there this A1, A2. I think that is fine. And this one we have B1, B2. Then we have X and Y. So when you want Q, it is X. Then P is A1. So PQ is X minus A1. Now let's go to the horizontal distance Cn. Cn is projected to QR. If you look at on the x-axis, QR is the same as Cn, which is R minus Q. Now our R is B1. You can see that. X, we are considering X first. And our R position, it is R minus Q. Our Q is X. Good. Now let's do the same for Y very quickly. Now for Y, the vertical distance we need is Cm. Now if you look at Cm, it is the same as Cq, which is the total vertical distance minus Mq. So Cq minus Mq. Now our Cq vertical position is Y, the total distance, and our Mq is A2, the Y coordinate on A, which is A2. Now we continue to the vertical distance Bn. So we have Bn. Now Bn will be the total vertical distance, which is V2. Okay, let me write the formula first to avoid shortcut. Bn will be Br minus Nr. The distance from B to R minus N to R. Now the distance from B to R is V2. Now the distance from N to R is the same as C to Q, which is Y. Now you have equipped yourself with the positions of what you want to derive. Good. We're moving well. Now we have similar triangles. We can have a triangle AMC is similar to triangle CNB. Now from that, we can see clearly that the ratio of AC to CB is the same as when we consider the horizontal distance AM for the first triangle divided by CN for the second triangle. This is also true, the ratio AC over CB. Remember we start with X, now we go to Y. Again, AC over CB is the same as vertical distance CM for the first triangle divided by BN. Now for X, AC is M, divide this by N, is the same as AM. AM we already solved up there is X minus A1. Divide this by Cn, which is B1 minus X. Cross multiply, that is M through that, and then N on that. When you do that math, you can see M B1 minus M X will be equals to N X minus N A1. When you collect like terms and rearrange, because that is exactly what you want, so we can have this closed here so that we can extend. Now when you collect like terms and rearrange, what do I mean? That you bring x's together and also take this side. When that happens, we'll have mx plus nx to be equals to m b1 plus n a1. Factorizing x, we'll have x into m plus n divided by equals to mb1 plus n a1. Good. Now, once we are done, we get x by dividing by m plus n. So x equals to m b1 plus n a1 divided by m plus n. Now that is that. We are done with x. Now let's find y on this next ratio here. AC is still m over n to be equals to cm, which is y minus a2, divided by bn, which is b2 minus y. When you cross, you'll have m b2 minus m y. This is exactly equals to ny minus n a2. Rearranging, bringing y together, we'll have my plus ny. Now, on the other side, we'll have m b2 plus n a2. Factorizing y, we have y into m plus n to be equals to m b2 plus n a2. Now y, if you divide by m plus n, then y will be m b2 plus n a2. All this you divide by m plus n, which is actually the same here, only that we deal with one. Of course, ones are for x and twos are for y. You can see from the vectors, 2 is for j and ones are for I. Now we want to reduce our ratio into a simpler form. We'll move that one down. Now to do that, we are going to have to combine the two. Now our C vector will be equals to m b1 plus, we collect b together, so mb1 plus mb2. Remember this is j, and this one is I. And then just have this together, then plus, you group the other one, n a1 I plus n a2 j. So I take m together. Remember on y we have j, x we have I. Same to a, n a1 and n a2. Then all this you divide by m plus n. Now finally we can factorize m to have m into b1 I plus b2 j plus, you can factorize n into a1 I plus a2 j. Now all this you divide by m plus n, common denominator. Now when you look at the vectors you are given, b1i plus b2j, b1i plus b2j is b, while a1i plus a2j is a. So this is vector b, that is what I mean. This is vector b, while this is vector a. Now, the simplest form of the internal ratio theorem for internal division will be m times vector b plus n times vector a. I divide this by m plus n. Now, that is how we get the ratio theorem for internal division of a line in simplest form. Or the more complicated one, or in complex, we can have what we had up, yx, which is m b1 plus n a1, all divided by m plus n, comma, then we have m b2 plus n a2 divided by m plus n. So these are the coordinates of x and y. So this is x and this is y. Good. So we can get this, or we can use this. Okay, now we go to the next thing. Now that is that. The next thing is on external division. So we'll follow the same procedure, but a little bit different. I'll move this down because we need this space. Good. Now I'll draw the XY coordinate the way I did before for internal division, but we'll simply have a small difference. So this one is X. Now let me draw Y coordinate. It's perpendicular to X, so this will be Y. Now I have here as my Y. Now I have my O, the way we did. Now we need our segment, which is AB. We'll have it somewhere in orange, just the way we did before. That is my segment. Good. Now once I have my segment, I need to put the positions. Now we have our A, and then we have our B. But now C is dividing the line externally. So C is outside AB. Remember, AB is inside. So this is AB, but C is dividing AB externally. So you see, in this case, C is outside AB, while in the internal division, C is inside AB. So if that is the case, then there's something you should know. And I'm going to put that. So from here to here will be our M, and then from here to here will be our N. Now that is a difference. So it means we have a very big triangle to see first, and then a small triangle on it. So let's extend or project our ABC on the x-axis. So I'll do that. So I'll project A on the x-axis. I'll do to B on that. And then finally I do to C. Good. Now once that is done, I'll now call them the same way I did. So this will be point P, this will be point Q, and this is point R. Now, the coordinates you remember, this is A1, A2. Now B is B1, B2, remember this, and C is XY, which we want. Now let me have the horizontal positions that now give us our triangle. Now the first one will be the big one. Of course, you know why? Because C is in an external division. So this makes the difference. And then the second one is the small triangle on top here. Good, for N and for M. So our first triangle for M is the bigger one, where this is 90, and then this is also 90. Okay, this is N. Now, when you check carefully, this will be our M, our N, because it's the second one, so that we maintain the positions. This will be our N, and then the first one was M, the bigger triangle. Now, working out this the same way we did with the other one, with X, you remember, and then after X, we have Y. Now, doing the same thing, we'll have our X here. So on our X, we have the distance AM. AM is projected on the x-axis as PR. So A to M is projected at P to R. So which is simply R minus P. Now when you look at this carefully, R, the distance horizontal, R is X. And P, the distance is A1 for X. Now let's get the small distance BN, which is still horizontal. Now BN is projected as QR on the x-axis. Now QR is R minus Q. Now let's prove on. R is X still, while Q is B1. You can see where BQ is B1. We are still dealing with X. Now let's do the same for Y. Maybe just to maintain this, let me put it here, and then we'll consider going in that direction to the left. Now for Y, we have vertical distance. For the first triangle, the vertical distance is CM. Now when you look at the diagram, CM is the total distance C to R minus C to R. So you have C to M is C to R minus MR, and see MR down there. Now C to R is the vertical distance Y, while M to R is simply the same as AP, which is A2. Now we have the small distance Cn for the vertical again. Now Cn again is C to R minus, so C to R minus NR. Now C to R is still Y, while NR is the same as BQ, which is B2. We are now talking about vertical positions. Now, we have similar triangles. So which similar triangles are similar? So triangle AMC is similar to triangle, maybe small one, BNC. Now, if that is the case, then we can compare. We can compare AC, which is for the bigger triangle, divided by BC, which is a smaller triangle, to be equals to the base AM divided by the base of the smaller triangle BN. And this is for X. Now we do the same for Y. Still AC over BC is the same as the height for the bigger triangle, which is CM, divided by the height of the smaller triangle, which is CN. So we are going to work out this one the way we did before with the other one. This one reached here. So let's do that, and we can also separate this. Okay, let me not have many lines. Now on this side, we have AC from our diagram. AC is the same as M over N, which is BC. You can see BC is N. Now AM from our derivation up here is X minus A1, while BN is X minus B1. Now cross multiply M times this and N times this. So M times X is MX minus MB1. And then N times X is NX minus NA1. Now collect X together. This comes this side and this comes the other side. When NX comes this side, we'll have MX minus NX. Now on the other side, if we take MB1 negative MB crossing equal sign, it will become positive MB1 minus NA1. Good. Now let's proceed. So to proceed, we factorize X. So we'll have X into M minus N to be equals to MB1 minus NA1. Now find the value of X by dividing by M minus N. So X is equals to MB1 minus NA1. All this divided by M minus N. Let's do the same for Y. AC is M over N to be equals to CM, which is Y, minus A2 over B over CN. CM is Y minus A2, CN is Y minus B2. Cross multiply, MY minus MB2 will be equals to NY minus NA2. Rearrange MY minus NY to be equals to MB2 minus NA2. Factorize Y into M minus N equals to MB2 minus NA2. Now, find y by dividing by m minus n. Y is equals to b, mb2 minus n, a2. All this divided by m minus n. Now we do the same the way we did with the other one. So we collect i's together. So our c, which divide the line externally, c vector, will be mb1. Then we bring b2. So this is I. Then we have b2 here. So we have mb1 plus mb2 because we need m together. J. Then close this and then minus because of this negative. Then you can create a bracket for n. We have n a1i. Now for us to maintain the minus for this, we need to have a plus here. So n a2j. Now since we have a common denominator, all this over m minus n. So why are we having positive here? So that negative times positive give us negative na2, na2. Now we have that. Now we proceed by factorizing m. So m into b1 I plus b2 j, close the bracket, minus n is common, into a1 I plus a2 j. All this you divide by the common denominator m minus n. Remember, this is this, and that is that. Now finally, we have what we said. b1i plus b2j is vector b. We were given that. a1i plus a2j is vector a. Now we can simply say for external division of a line, the point C or the position vector C is given by m b vector minus n a vector. Divide this by m minus n. Or we can just put them together the way they were as a coordinate, so that we are going to have as a coordinate, so that we are going to have m b1 plus, not plus, sorry, mb1, we're just picking it from up there, minus n a1, all divided by m minus n, comma, this is for x. Then we have m b2 minus n a2. All this divided by m minus n, and this is for y part. So the coordinate system in coordinates, this is what we have. Simplest form, we have mb minus na over m minus n. So that is for external division. Here we add for internal division. We subtract for external division. I hope that is clear for the first question. Now the second question, which is B, we apply what we learn. So we apply the formula to solve the problem. Now the first question B for application is find the ratio in which the point R divides the line segment joining the points P and Q externally. So R position vector, so let me have it as a vector. R position vector for external division will be given by M times, because this is PQ, so MQ vector minus N P vector. Divide this by M minus N. I've just applied what we have derived. Remember, our B is now our Q, that is why MQ. Our A is our P, NP, and then our ratio is M minus N. So we are applying what we learned. Now our R we were given, the R vector we were given is 5, negative 3, and then 2. We are given that to be equals to M into Q vector we have 4, negative 1, 3. Then minus n into p vector is 2, 3, 1. And all this we are dividing by m minus n. So that is what we have. So when we simplified this, on the other part is we are going to multiply by m. So what are we going to have? On the top part, we'll have 4m, then negative m, then 3m. Then this is minus 2n, then 3n, then n. And just multiply across by that. All this divide by m minus n. So that is what we have. And then this side we have 5 minus 3, then 2. Remember, we are asked to solve for the ratio, so our deal here is to ensure you get the value of n from this problem. Now, let's calculate for x. We need to get the same ratio for x, same ratio for y, and same ratio for z. So let's start with x. 5 equals to, you just get the top position. 5 equals to 4m minus 2n, all divided by m minus n over 1. Now when you cross multiply, we are solving for ratio in x. So this is for x. We need to get the same ratio. We need to verify. So this will be the same as 5m when you cross multiply minus 5n to be equals to 4m minus 2m. If you collect m's together, we have 5m minus 4m to be equals to 5n minus 2n. Now this gives you m to be equals to 3n. Now the ratio divided by n divided by n. Now you see the ratio m over n is simply 3 over 1. So the ratio is 3 to 1. Now we need to verify with y. So let's see for y. For y, we pick the middle term. So negative 3 equals to negative m minus 3n. We only pick the middle part, negative 3 and this. And all this divided by m minus n. When you cross 3 times this will be negative 3m plus 3n to be equals to negative m minus 3n. Collect m's together. Negative 3m plus m equals to negative 3n minus 3n. When you work this out, you get negative. What happened? Negative 3m times m. Negative 3m times m is 3m. Then negative 3 times 3n is 3n. I think that is true. Now when you collect, this is negative m minus 3. I've just picked it the way it is. When you collect, m comes this side, it's a positive, then n goes the other side, it's a negative. So this is likely to be negative 3m plus mm, that is negative 2m. On the other side, we have negative 6n. When you rearrange and divide by n, so we divide here by negative 2, we divide here by negative 2, we divide by n also by n, this cancels that, and this cancels that, we get the ratio m over n to be equals to 3 over 1. So the ratio again is the same, 3 to 1. So z must also have the same ratio. If it doesn't have the same ratio, then it means the lines does not lie, the points does not lie in the same line. So we will just pick, I will just say we'll not pick the ratio because that simply tells you the points do not lie in the same line. So let's find for x, z. So for z, we pick the lower term. So that is 2 equals to 3m minus n. So 3m minus n. All this you divide by m minus n. So we are going to have, if you cross 2 times m, is 2m minus 2n equals to 3m minus n. When you do your maths, you'll have 2m minus 3m to be equals to negative n plus 2n. Now on this side, we'll have negative m. On the other side, we need to have n again. So this gives us a ratio of, if we divide by n and divide by n, and also by negative, we get something like m over n is equals to 1 equals to negative 1 over 1. So this gives you a ratio of negative 1 to 1. Now this is wrong. Let me check. 2 times m is 2m. Then 2 times n is 2n. Then 3m minus n. When you find 3m this side, 2m minus m, then when you take this one the other side, we have negative n plus 2n. So this gives you negative m, while the other side gives you n. Yeah. So this simply tells you that the points that don't lie in a straight line. This confirms that, it confirms, but we also wanted z to agree. So if z doesn't agree with the rest, that means the points P, Q, R are not lying on a straight line. The ratio has to be the same. So that is why we get different ratio. So if we got to the same ratio by verifying, so you need to get the first one and verify with the other ones to prove that you are correct. If even one is not the same, then the points P, Q, R are not lying on the straight line. In simple terms, to avoid this story here, we can simply say the point A, P, Q, R are not collinear. I think that is the easiest. As mathematician, instead of writing all those things lying, are not collinear. Okay, we proceed to the last question. A line segment join this and this. Find the position vector P which divide AB internally in the ratio of 2 to 1. So that is internal division. We want vector P, which will be M times vector B plus N times vector A. And this divided by M plus N. Now, our M, remember from our ratio, M to N is 2 to 1. Now let's put them back. Now our M is 2 times the vector B, which is 5, 3 minus 2. Then plus, this is internal division, so N, which is 1, times vector A, which is 2, negative 3, 4. Then all this you divide by 2 plus 1. Now when we proceed, we have a third, because of 2 plus 1, 3, then work out 2 times 5 is 10, 2 times 3 is 6, and 2 times negative 2 is negative 4. Then plus 1 times everything here is just the same thing, so it doesn't change their values. Now when you proceed with this, you get your vector P is equals to a third into 10 plus 2 is 12, 6 plus negative 3 is 3, and negative 4 plus 4 is 0. Now multiply each by a third. We have 1 over 3 times 12 is 4, 1 over 3 times 3 is 1, 1 over 3 times 0 is 0. So your position vector that divides the line internally will be 4i plus j. Remember k is 0. So that is this one is the position vector P that divides the line internally in the ratio of 2 to 1. So that marked the end of revision 1, which was on ratio theorem. We started from deriving the ratio theorem on internal division of a line, which is this, and You can get coordinates using even this or this. Then we have derivation of the external division of a line, ratio theorem. Then we applied it on finding the ratio. Unfortunately, we couldn't say the ratio is 3:1 because the z-axis failed. So it means there might be a typo in this question, or PQR are not collinear. And that is what we have. Now we apply the formula of internal division and got the position vector P. And that marked the end of revision 1.